Hey guys, here's the other example for our information today. So we have a rock and a string, and you can kind of read what the problem says. But it makes an angle with the vertical. And here's my rock of mass M tied to the string of length L with my theta with the vertical. So that's kind of what it looks like. And what it's doing is it's going in a horizontal circle. So it's kind of hard to see it on a 2D thing, but here's my motion of the circle, right? There's my velocity as it's spinning about, okay? And so what we do is we kind of have to figure out what's going on here. Because it's going in a horizontal motion here, this is the direction of the centripetal acceleration, which in turn is the direction of the centripetal force. The radius of the circle is this value here. So good thing they gave us the length of the string. It's basically the hypotenuse of the triangle. So we're going to be able to figure out what the radius is using a little bit of trig. And that would end up giving us the value L sine theta. So I know the radius of the horizontal circle is L sine theta. The rock is going to have mg. Okay, so let's use Newton's second law and try to generate some equations here. So here's my mass right here. And I'm going to have the force of gravity of the rock, let's call that F sub g. We have the tension of the string going off at this angle. I'm going to call that F sub t. I'm going to draw my theta here. And a really important piece of this is, remember, the centripetal acceleration is directed inwards. So I'm going to draw my arrow over here, A sub c, which means the centripetal force is also directed inwards. So there is a net force on the rock. The net force is the centripetal force, okay? And we're going to call everything going to the left positive and over here negative, just because it's a little bit easier that way. So the net force on the rock is the tension in the x direction and that's it. So the tension in the x direction is the centripetal force. So we can write that Ft sine theta equals mass of the rock times the centripetal acceleration of the rock. There's that guy there. And from there, we can use this equation, because we should remember that the centripetal acceleration is v squared over r. So we're going to start plugging some things in. So the centripetal, or the tension, is the Ft sine theta, mass of the rock, times v squared over r. Remember, r is L sine theta. So Ft sine theta equals mv squared over L sine theta. And it looks like we were supposed to solve for v squared, so we can just do a little bit of algebra and finish this guy out. So we'll go this way. So L sine theta times Ft sine theta over the mass of the rock, take the square root of that, and this is the expression used to figure out how fast that rock moves in a circle. And so this is basically going to be the style of question we're going to start using. There's a little bit more math involved, and I think you guys will be all right. All right, I'll catch you later. Bye.